This? Yes, it's on the slides. But there's also, if you look on the GitHub, well, Ben's coming up, but if you go to the GitHub link, you can download the schedules as well. You'll see under the GitHub, you'll see labs, you'll see presentations, and you'll also see events. Under events, you'll see New York, today's date, and then underneath that, you'll have a schedules folder. All the schedules are in there. You'll also have the electronic copy of everything that you were given, including the speaker bios and stuff like that. And I strongly encourage you, as you're tweeting, as you're socializing, please include the speaker Twitter handle in there too. We really want to show them that we appreciate their energy in putting this together for us. Yeah. This is a standalone exam. Yeah.
So this is the data access stuff. So is this coming up okay? Yeah.
Looks good.
I'm Benjamin Day, owner of Benjamin Day Consulting, based out of Brookline, Massachusetts. Consultant, coach, and trainer. I'm a Scrum guy, a DevOps guy, a Team Foundation Server guy, wildly passionate about software testing, software architecture, and especially unit testing. Everyone here is writing unit tests with their code, right? Okay, cool.
One hand, two hands.
Come on, the rest of you are all bad people. No. So I'm Microsoft MVP for Visual Studio ALM, which means that I go into companies, tell them that everything they do is wrong, they ignore me, and I send them a bill. I'm a Pluralsight author, so if you've got a pluralsight.com account, you can go watch my stuff. I'm a Scrum.org trainer, so that's Ken Schwaber's company, based out of Burlington, Massachusetts. And also, to answer the question that is on everyone's mind, yes, I did wake up, open my suitcase, and realize I had not brought shaving cream or a razor. So away we go. At BenDay on Twitter, so if you want to heckle or tag me along with the hashtag for this event, go for it. For that Pluralsight stuff, so big classes, I've got Scrum Master Skills, DevOps with TFS 2015. I've got a whole bunch of other ones, and then the DevOps with TFS 2017 is coming soon, and I'm going to do a lot of stuff with Azure in that, getting that sort of DevOps thing going from on-prem into Azure Cloud, and a bunch of other scenarios. So, on with the show. Thank you very much. Goodbye. All right, so we are in this part right here. So we're going a little bit out of order. So number 3, design an application storage and data access strategy. Zooming in on that a little bit. This is an actual screenshot from the objective domain for the exam. So what we're trying to do is we're trying to do 2 things. So design the data storage strategy and then select the appropriate storage option. So we're going to be covering stuff like Azure Table Storage, SQL in the cloud, DocumentDB, whole bunch of other stuff right there. And you have to kind of know what they're all for so that you can decide what is the right option. Make sense so far? All right. So the products we're caring about, table storage, blob storage. So for those of you that have been using Azure for a while, think Azure Storage is what it used to be called. SQL database, so SQL Server in the cloud, the hosted, is that platform as a service or software as a service? It's kind of right in the middle, right? You could make the argument, like, okay. They actually have it as past SQL? Smartest kid in class right here. DocumentDB, so this gets a little bit crazy. So as I was going through and doing these slides, there's all that Cosmos DB stuff that just got announced at Build a couple weeks ago, right? Was it Build or one of the big conferences? So that has just taken the storage snow globe and just shook it like crazy. So it was a little hard to find stuff about DocumentDB because now DocumentDB sits under Cosmos DB. So they've gone and updated all of the stuff on the Azure website and all the documentation to say Cosmos DB. But guess what? The Cosmos DB stuff hasn't made it onto the exam yet. So good luck. So just keep that in mind. So as you go through, as you read the documentation for Cosmos DB, you kind of have to be mentally editing out all the other stuff and focusing on just the stuff that says DocumentDB. MongoDB, we're going to talk about that briefly. MySQL. And then we're going to talk about security options here. So the stuff that comes into security for SQL database and for Azure Storage. Then finally, we're getting into the performance and hybrid scenarios of on-prem, off-prem. All right. So designing data storage options. So the big things, table storage. The idea here is that it's NoSQL. So we're not doing schema. It's basically glorified key value pairs. Fast data access, and it's relatively cheap in comparison to other options. SQL database, SQL Server in the cloud, it's the full relational stuff that we've come to know and love. Tables, primary keys, foreign keys, indexes, yada, yada, yada. It's all in there. MySQL, another relational option. It's an open source product. It's there. Just know that it exists. DocumentDB, another NoSQL option. And this is getting into storing documents. When I think documents, I don't mean PDFs or Word documents. I'm thinking data formatted in JSON, and you're using a JavaScript or JavaScript-like model for manipulating that stuff. First kind of tip as an architect. I'm at this place right now where I have an app that I've written that manages recipes for cocktails. And it is my over-engineered sample application that I use to teach myself stuff. And I kind of look at what it costs to run that on Azure. And since it's coming out of my own pocket, I'm really cost-sensitive. I've got SQL database on the back end, some mix of table storage for images. But what I really want to do is I want to get rid of the SQL database thing because it's something that I could theoretically get rid of, and I want to move it into table storage. Big difference here between table storage and DocumentDB is what you have for query operators. So one of the ones that I want really badly is the contains operator, also the like wildcard operator that you'd have in SQL Server. You don't have that in table storage. So part of the reason that you've got sort of limitations on what you have for queryability is that they're trying to go for that fast data access and super, super scalable. Now, if you need that kind of query power, you're now thinking about SQL database or DocumentDB. DocumentDB gets you high performance, but it's not relational. So I actually went to one of the first or second software design reviews for Microsoft Azure way before it was announced. And one of the things that really blew my mind was that the team was saying that relational databases cannot scale to crazy huge scale, the end. Theoretically impossible. Now, I have a degree in music performance, so I can't tell you the theoretical reasons why. I'm just going to take their word for it. So one of the things that Microsoft is trying to do with table storage is try to get something that actually can scale infinitely. And that relational stuff is the key to the problem for why it doesn't scale to zillions and zillions and zillions and zillions, like running Facebook kind of thing. Getting to DocumentDB, DocumentDB, not relational, scales really, really well, but also has great query operators in it. Blob Storage, related to table storage over here. It's for unstructured data, so images, disks, all that kind of fun stuff. MongoDB is another NoSQL option that's kind of like table storage. All right, first exam tip. Know the various storage types and their uses. And keep in mind that a lot of times they're going to try to get you to think about decoupling your architecture. And that's usually using queues.
Yeah, and I'll add to that. You'll see probably this tip in a couple of other sessions as well. If you see a similar tip in multiple sessions, that should be a really good hint that you're going to see it on the test. Just bear that in mind. This one in particular is the thing is that the exam is broken down into questions on each topic of the exam, and there's just a giant pool of those questions. The ones that are on your exam are pulled from that queue, and they have the questions in that queue have a weighting. So some of them you'll, like almost everybody will get, but there's no guarantee of what questions you're going to get. But this one, you'll see it, and a lot of others you'll see multiple times, like when we get into networking and stuff like that. You'll see multiple times. If you see it multiple times, make note. You better learn it if you want to pass that question.
Now, something to sort of plant in your head as architects. So how many of you work as software architects day to day? Some of you. As like a building architect? All right, whatever. We'll just keep going. How about developers? What do you all do here? Like that was, it's like the Office Space thing. What is it you'd say you do here?
Operations. Who's in operations?
Okay.
IT people.
There you go.
There's a big section there.
So lessons from architecture for IT ops people. That decoupling and the queue thing is really important because thinking about failover. So if you've built your system so that you can kind of fire stuff off into a queue and the queue is reasonably reliable, as opposed to firing off a message that has to be received by some endpoint in another system, it's loose coupling of your architecture versus tight coupling. That's the thing we're trying to go for with this. It'll show up storage questions, but also that's the overall architectural principle in the apps. Okay. All right, number 2. Oh, that's a little hard to read. Shared access signature, SAS. Make sure that you understand what that is about. I'll do a little bit more on that in a second. SQL database, basically the same kind of scalability model of what you would have for on-prem SQL Server. It's just in the cloud. Although you do have to worry about the operations per second kind of stuff. Because generally, so I ran into this with my over-engineered application. I was on a cheaper hosting layer of SQL database, and it just sometimes would just lock up, and I wouldn't know why. And it was because it ran out. It was, my application was being too busy against SQL Server, and it was exhausting my super cheap tier, and it just bombed out. You don't generally have to worry about that for on-prem SQL Server, because on-prem SQL Server isn't just going to stop working if you throw too much work at it. It's just going to slow down. So the way that it scales is a little bit different. Dan, do you want to say anything on the download and use Storage Explorer?
Just what Storage Explorer is. It gives you the capability from a graphical user interface to mount your Azure Storage and then navigate through it like a file explorer. So it's kind of cool, and it will allow you to go deeper into it. So you can see inside of folders, create folders. Actually, I'm not sure if it lets you create, but it lets you view all the stuff that's there.
Yeah. Okay. Actually, and sort of going on top of this, how many of you have heard of Fiddler? Okay. So it's a network traffic debugging tool. It would be worth it for you to open up Storage Explorer and open up Fiddler at the same time and watch what is going over the wire. So that's one of those sort of pro tips for software architecture. If you only know how the GUI works, then when you need to debug stuff that is going wrong, you're going to have a little trouble. But if you understand what it's actually talking under the surface, it might actually give you some hints sometimes.
Yeah, some of those hints are going to include performance hits, right? Whenever you go from one record to the next, how much additional information is coming down, and is it bringing down 3 levels deep that you don't need yet because you haven't clicked on it? Those are some of the kind of the performance things that you'll be looking at. So it's great information.
Okay. All right, let's dive into table storage and blob storage. So Azure Table Storage, like I said before, is NoSQL, meaning that there's no schema. It's basically key value pair, kind of fun stuff like that. Your queries are going to be OData-based queries or API-based queries. So if you're writing a .NET application, there is a nice library that will just give you C#, VB.NET, whatever it is, that will allow you to talk and write queries against that. There are libraries for a bunch of other platforms as well. Go check that out. As far as consistency of read-write goes, Data is consistent when read from another client immediately after insert or update. Okay? Big idea here is store lots of data for cheap. So think this one is the cost-effective option. It's got It's got a bunch of geo-redundancy options. So if you go for the lowest level, it's going to store 3 copies inside of one region. Inside of one data center. If you go for the geo-redundant options, it will then put 3 copies across the region and 3 copies in another region. So that's helpful for that kind of stuff. There's a bunch of different failover options. That is kind of creepy. A bunch of different failover options. It's worth checking out the documentation on that stuff. Give it a skim. Accessing table storage through the API looks like this. Should I walk through this stuff or should I skip over this stuff? You're interested. OK. So right up at the top, we're going to go for our cloud storage account. So cloud storage account gets us the credentials that allows us to talk to the storage account, allows us to talk to Azure. There's going to be some information about what protocol you're going to be talking about, what your account name is, and what your account key is. So as you're writing an application, if your teams use Git especially, definitely make sure that they are not putting your account key into app config or web config. Especially with Git, if you put that in there and you commit it, push it up, it's really hard to get it out later on, if not literally impossible. So be careful not to put secrets into your source control repository. So once you've got that instance of your cloud storage account, if you want to access table storage, it's got a utility method off there that says create cloud table client. That gets you a client. From there, you can go reference tables. So in this case, we're referencing customers table. So that gets us an object that represents that, and then we can start throwing entities into it. So if you're thinking about relational databases, you're thinking about rows. In this case, you're thinking about entities. Now, relational database, you've got a schema that governs how many columns are going to be in that, what the primary key is per row. In Table Store, there is no restriction at all that you have the same number of columns on every single row. And honestly, if you start thinking through it, you could put this as customer info. And you might have one record that has customer mailing address information, and another record right below it that has customer phone numbers on it, and another one that has customer orders. There's no reason that you couldn't put, it's just key value pairs, and there's nothing in it that says that every single record in that has to be the same. I think that this is really interesting, especially for DevOps, this NoSQL thing. Because one of the big problems we wrestle with in DevOps is managing our relational database schema at the same time that we're putting out binaries. Now, if you have a system like this that doesn't really necessarily care about what your schema looks like, and your application has to react to whatever data is coming out, that kind of frees you up in the DevOps perspective of you don't have to worry about the schema anymore, because the application manages it, because you don't have this big, nasty relational database engine that is saying no, 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 whenever something doesn't match. Does that make sense to anybody? Yeah, go ahead. Hang on one second. I didn't hear what you said. So, yeah, okay. So if it's a name value pair, what does that really mean? So there's I'm going to butcher the names of the columns that come by default. It's row key, partition key. Those are the 2 required. And then after that, you can put whatever values you want. So row key, partition key, first name, last name, email address, phone number, type of dog they like, height of their first child, and just keep putting that across. It's this horizontal record. What are the data types? Are you asking what are the data types? It's whatever you want it to be. I think I'm going to take that question offline. Let's take that later on. Okay? All right. Moving on. So you get your customer entity. You've got an operation called insert. And then you're going to go back to that table and say execute your operation. If you want to do the retrieve, it's sort of the opposite. So you do your little query, pull it back out, and there's your information coming off a table store. Yeah, which is, I believe we have a link to it later on in the slide deck, right? Okay. All right, Azure Blob Storage. So another unstructured storage. I tend to think of this as kind of like the sister or the cousin to Azure Table Store. We've got the same kind of query stuff that we're doing, so OData and API based. And the idea here is that all blob stores start from a container. So in my case, it would be BenDay that sort of gives us this large scale container. Inside there, we just keep on going through. We've got a couple different kinds of blobs you can do. So block, append, and page. I'll go into those in a second. Once again, here's another store lots of data for cheap. And we've got the same kind of redundancy options that you have in Table Store. Definitely read this stuff. All right, so going into blob types. First is block blob, append blob, and page blob. Now, it's not literally only for these things, but I want you to sort of get in the mindset of what these things are about. So block blobs, I would think about storing images. So if you've got a website and you want to put your image stuff up there, that would be a great option for block blobs. Append blobs would be for logs. So append, you can only write to the end. So for log files, you're always tossing more stuff on there. Page blobs, the VMs in Azure run on page blobs. So use them for disks. There you go. Storage options. You've got your standard level and premium level. So standard has a max request rate of 20,000 IOPS. Premium storage is designed for things that are like Azure VMs, where you need high performance, low latency. Yeah. Dan, did you have anything you want to throw on the comment on the storage options?
Know the storage options. We've got some additional detail. Performance, on this particular exam, performance is going to be a big thing. So what kind of storage options do you need for a particular level of performance that you need? But also scalability is going to be important. The most important, though, is the type. So you need the type, the size, the performance. You need to know what those are and how those work together to give you the performance that you need to solve a problem. Because this exam is a lot about solving problems, not about what you can recite from memory. It's really about, I've got this challenge, how would you solve it, okay?
Yeah. 20,000 IOPS per storage account. That is something to definitely have in your mind.
Yeah, we've got that on further slides too. We really want to hit that one
I'm
hard
not sure that we
because
actually do.
That one will almost certainly be on the exam. Just remember storage account, 20,000.
I don't know if those slides made it into the final version of the deck.
Oh, well, we had to cut because of time, so
okay.
It's definitely something you need to know.
But, so continuing on from that, if you have scalability requirements that go beyond 20,000 IOPS, that now puts you into this place where you have to do some kind of a multiple storage account sharding algorithm inside your application. So think about that. That's how you're going to have to solve that, Raj.
I believe it's 500. Yeah.
So how does it play out with the storage space? So if I create a storage space with 10 VHDs in a different volume,
Yep.
I get linearly 5,000 IOPS, or what would it be?
It should be flat. Sorry, yeah, I have to repeat the question. So the question is, whenever you say you have X number of IOPS per disk, and you have multiple disks, is that going to be linear? In other words, are you getting different amounts of IOPS for different disks? And the answer is it should be flat. You should get those IOPS off of each disk. So if you're using something like storage spaces, then you, did we get that? We'll have some additional slides that might be hidden in the deck. Make sure you look at it. Because whenever you're doing something like storage spaces, there's other things that you have to turn on to make sure that you're spanning evenly across the disk. So there's a lot of settings that you can tweak. Hence, as an architect, you kind of need to know those. You're not, as an architect, you're not the guy that's out there building it, but you are the person that's out there that knows how to build it right. You might not know which buttons to push, but you know architecturally what the right solution needs to be, right? So yeah, you need to know all that stuff. The region is not really important as long as the technology that you want to deploy is available in that region, with a couple exceptions. When we get into tomorrow, when we talk about monitoring and stuff like that, region is definitely going to matter, but we'll talk more about that tomorrow.
That was a nice version of, these aren't the droids you're looking for.
Yeah. I'm sorry, I didn't understand that. Well, no, it's, so I'm going to paraphrase when I answer. The way that the blobs are read and written to they're nothing more than disks, right? They are disks. You're going to have reads, you're going to have access speeds and things that come into effect. Microsoft isn't doing anything magic that's going to like change what computers do. They're leveraging that hardware underneath, and they're in some cases putting limitations on it. And the reason those limitations are there is because it's a multi-tenant environment. You can't have one person. I know when I started my blog, I don't know, about 8 years ago, about 9 years ago. And when I first started my blog, I was running on 15,000 RPM drives on-prem, super duper machine. Tons of memory in it that wasn't being used for the most part, but I needed to be fast. And at Microsoft, we came out with Azure like 6 years ago, something like that. And I'm like, okay, everybody's pushing me to get my blog up on Azure, right? And I'm like, I don't want to do it. It's going to be slow. I don't want to do it. But I bit the bullet and I did. I was running my blog on-prem, state-of-the-art hardware, 15,000 RPM SAS drives. And when I moved it to Azure, it was faster. It was faster, right? They have some magic going on behind the scenes. The magic that they're doing is really in the automation and some of the software they're doing behind the scenes. But if you do the same thing and if I had put it on storage spaces, I would have got a performance boost. I didn't know that back then, right? In fact, I don't think storage spaces were even out back then. But Azure is kind of leading in the leading edge of where technology is. So Microsoft is putting all this great technology into Azure first, and then they're bringing it back to the data center. So under the covers, it's just hardware. So it's going to abide by the same limitations that you have in any hardware. It's not going to be magic. It's not going to just deliver you that. It's going to deliver it the same way the hardware delivers it to the service. Okay?
So if your app writes to the hardware in a bad way, it's going to perform just as poorly on-prem as it would in the cloud.
Yeah, but let me share with you, let me just finish that story out now that I think about it. It did eventually slow down in Azure. The reason it slowed down was because Azure realized that there's this noisy neighbor problem whenever you have it wide open. And so I got to run a super fast blog for about a year before they finally put in blocks, and it got back to what it was equivalent to on-prem once they started putting those, because I was the noisy neighbor. My blog was, I was the noisy neighbor, and I was stealing everybody else's bandwidth in IOPS and CPU or whatever they were doing, and then they put a cut to that. So they do have those software limitations to give you that quality of service and to guarantee that quality of service. So they're not actually giving you the full amount that is on that platter that's spec'd. They're giving you what they can deliver very, very consistent performance on. Okay?
All right, next topic, block blobs. So the idea, actually we spent a lot of time on blob storage so far already. So remember 3 types of blobs in Blob Store. So block, you're breaking the whatever you are trying to store into pieces. Each block has an ID. So the block size max is 100 megabytes, and you can do up to 50,000 blocks per blob. Now, the idea on this one is that you want to be able to efficiently do uploads of your stuff, especially when stuff gets large, because you can, with block blobs, do multi-threaded uploads. So if you're trying to, you could, like, let's say you're trying to push up a 100 meg file or something like that, cut it into pieces, 5 threads, each of 5 threads pushes out 20 megs worth of data.
And it does that automatically in the background. You don't have to like configure it, or it just, that's part of the service.
Yeah. So the idea is that once you get it up there, okay, so you get the block IDs for each piece that you're uploading. What do you do with those ID pieces? Like, do you put them into table storage? And the answer that I would say is that you don't really care about it once it's up. Once it's up, it's there, and then you reference it by what that, the blob becomes 1 at that point. So you'd have a reference to the top of it.
It's all abstracted, yeah.
Top, not all the IDs, if I'm correct, the IDs are only valid really while you're doing the upload.
That's correct. Yep.
As soon as it's done, it's gone.
Yeah, and we do have to move a little bit faster, so we might have to hold questions until the end of the session.
Okay.
So, apologies.
All right, bottom line here, storing documents, media files, backups. Good stuff right there. Append blobs, similar to block blobs, but it's optimized for append operations because you can only add to the end, and it's good for logs. Page blob, optimized for IaaS disks, supports random writes, and it's a collection of 512-byte pages, up to a maximum size of 1 terabyte. 2 different storage options, premium and standard. Yeah, questions on this one?
We intend to catch a question. We really have to move on, I think.
Okay, done. Thank you for no questions. Moving on. Replication. So 3 local redundant storage options, so 3 copies in 1 data center. And then you've got a zone redundant option that you can do, so 3 copies across a couple different facilities, or 1 and 2 regions. Geo redundant, so 3 copies in primary, 3 in a secondary with auto failover. And then there's another one, which is read access geo redundant storage. Definitely read up between the 2 of these, because they get kind of confusing, and that's why I'm moving on. Blob Access. So this is getting into some of the security stuff for blobs. So imagine that you're running a website and you're putting your images for your website up into Blob Store. Depending on what your security model is like, maybe you want all those images to be completely open to the public, in which case you would set your container for anonymous access. If you don't want that, let's say you've got a paid site and you don't want everyone just sort of grabbing all of your content if they haven't paid for it. Now we're getting into shared access signatures, SAS. The idea here is that for something that you are trying to serve up, you get this little key that gives certain permissions, and you hand that off along with the URL for that, that resource. So that'll give you the ability to start to ratchet that down. Additionally, from a security perspective and a performance perspective, rather than having to put, let's say that you're doing that image loading thing. If you didn't have shared access signatures available and shared access tokens, then you would have to have some kind of endpoint in your, let's say, ASP.NET application that would proxy the security for you. But what you're doing instead, let's say you're doing ASP.NET MVC, when you go to draw that page, you're also going to publish out the URLs for the images that go on that page, and you would have had to have gotten a shared access token for each of the images on that page as you're drawing the page. Okay? So that kind of changes the way that performance goes. So instead of all the images having to go back to your server or your, whatever's hosting your application, it now says, okay, images go back to my Blob Storage, and now that's Microsoft Azure's hosting and performance problem as opposed to the core of your application. Make sense? That's kind of on the exam, from what I understand. We were talking about this yesterday. That architectural decision there of, do we want all of our image data going through a security layer in our app, or do we want to say, okay, I know who this person is, here's a token to access the resources, go look over here. Two different models of working with that stuff. So on those shared access signatures, you can specify a time interval, so start and end time for the permissions, read, write, and or delete for those things. So it's not just for read. You also can say, okay, we're doing a document management system. And now you've authenticated, and I'm going to give you the ability to read, write, delete to this location right here while you upload some files. You have options for IP range, address range permissions, what protocols you're supporting. And this is going to be really hard to see, but this is what this would look like. So
on the slides, you guys can download them. Those that are on online can download them as well.
So left-hand side, I'll just talk it through. You've got the resource, so the thing that the thing you have stored in the blob, and then question mark, and then the rest of the URL has your SAS token in it. So if you're going through and surfing around on applications that are hosted on Azure, and you start noticing those really crazy URLs, it's probably SAS tokens. All right, let's go into Blob Encryption. So you've got two different options, client-side or server-side. So client-side would do the encryption and decryption through the storage client library for .NET. I don't know off the top of my head if that is available for the other platforms that are supported for APIs. I suspect the answer is yes, but definitely look that up. Server-side will give you that data at rest encryption, where the encryption is happening up on the server as opposed to client. All right, how are we doing on time? 10 minutes. So getting into performance and storage limits, definitely go read this. That URL will be really helpful. So some of the big ones that, actually Dan went through this and highlighted a bunch of stuff. These are the ones that Dan thinks are especially important. So number of storage accounts per subscription, 200. Terabytes per storage account, 500 terabytes, that's an insane amount of storage. Yeah, go through, rather than me reading slides at you, this is in the deck, pull it from GitHub. Dan, anything you want to say?
Just, you got to read these. You got to kind of have a good picture. Remember, you don't have to get 100% on the exam, but the more of these little details that you can remember, the better off you'll be at getting the easy questions right. They're also pretty important whenever you want to design a strategy for actually implementing a solution.
The strategy for implementing a solution that gets really, really big. Like, this is, if you're looking at the sizes here, we're getting into gigantic amounts of traffic and gigantic amounts of storage. So a lot of us actually in our careers might not ever actually hit up against the limits.
But as an architect, you need to understand what those limits are so you can avoid them.
Yes, it is all about avoiding gigantic problems. I'm going to tell a quick story. So I worked with this guy a zillion years ago, and he was the software architect on this project. And he was so he was in downtown Boston, and he was super psyched because he just bought this gigantic pickup truck, like just monster pickup. And he was like, I'm going to pick up my truck today, going to pick up my truck today. He was so excited. Next day, I came in, it's like, how's the truck? And he looks so crushed. He's just super sad and super down. And I'm like, what's the matter? He's like, truck doesn't fit in any of the parking garages within a mile of here. Inside my head, I'm like, maybe you shouldn't be the software architect. Okay, so also look at this page. Yep.
Important on here are the IOPS, the queues, the number of messages. You can really expect to see some questions off of these that are highlighted. And you might see questions off of some of the others, but definitely give those a scan a few times.
Okay. All right. Dan, you want to talk to this one?
Sure. When it comes to bandwidth, you need to make sure that you understand how to deliver a sufficient bandwidth for that workload. So when you're designing a solution, you've got to not only consider an individual disk, but at the virtual machine level, what you can get out of premium storage, what you can get out of a virtual machine, what you can get out of an individual disk, how you're striping those disks, etc. But not only IOPS, but also capacity, right? You have to consider IOPS and capacity kind of at the same time. To give you, if you have a high IOPS workload, you're probably going to want to go to premium storage. So you'll want to, you kind of look through that that post on the premium storage and the IOPS for your throughput and VM limits.
This one's yours too.
You can expect to see these on the exam. That's why they're an exam tip. These are scalability targets. So scalability target basically is what you can scale up to, right? So 35 terabytes for disk capacity, 10 terabytes for a snapshot capacity. So if you're doing snapshot backups, that's where you're limited to, is your 10 terabytes. So depending on how you're doing it, and then from a bandwidth standpoint, up to 50 gigabytes per second for premium storage accounts.
Gigabits. So, you said gigabytes.
Oh, sorry. Yeah, gigabits. Thank you. And that's calculated inbound plus outbound, right? So it's not 50 gigabits inbound and 50 gigabits outbound. It's combined 50 gigabits. So per second. But that's per second. That's a lot of throughput. Using storage space striping. I mentioned this a couple slides ago, but or earlier. You do want to look at this because by default, your columns for your disk are going to be set up to 8 when you're setting up storage spaces.
Can you give a 10-second overview of storage spaces?
Sure. Storage spaces is a, let's call it a software RAID, but it's so much more than that. It is it's not what RAID was, 5-10 years ago. It gives you all the capabilities of RAID and so much more. So you're able to use regular disks. You don't have to use high-end disks. You can add disks. You can provision thinly provisioned disk. So like on a 2 terabyte disk, I could create an 80 terabyte volume if I wanted to, right? And then you can add additional disks to that pool as you need the capacity without having to recreate volumes and format and all that kind of crap. So
this is relevant in the cloud just like it is relevant on-prem because
absolutely.
in this case, you would be building your own VMs, so you're managing your own disk.
Yeah, and the big thing about this is recognize that you have to set up the columns. The default is 8, but by doing that, you're not actually getting the best performance out of it. So you don't necessarily want to keep the default. So just look at this article and kind of understand what it's talking about there. I don't know if you're going to see this on the test or not, but from an architecture standpoint, you kind of need to know it. So I'm guessing that at least some people will have it on their test. pay attention to I/O and IOPS throughout. For this particular exam, and also whenever you're architecting solutions, the things that your applications are going to get hung up on, or your systems are going to get hung up on, is I need more power. More power, Scotty. Is it Scotty, right?
Yeah, sounds good.
That's what IOPS is all about. It's how much performance you're getting out of the different layers. So understand your sizes and understand your IOPS so you can make sure you're architecting your solution that's not going to fail in 2 years because you accounted for the capacity, but you didn't account for the speed, those kinds of things. So pay attention to that URL and maybe take a look at it.
Cool. All right, I'm down to 5 minutes, so I'm going to bang through a whole bunch of stuff. We've got the link for Azure Storage samples, table labs for .NET. I believe there are labs for a bunch of other different languages as well, so it's probably right nearby this. Blob labs are up there. SAS labs are there. And now let's talk about SQL database. So Azure SQL database, think SQL Server in the cloud. It's relational. 4 different service tiers, so basic, standard, premium, and premium RS. So on that basic tier, small size, low traffic, single active operation. Remember I was talking about on my app that I'd written, I was doing the absolute cheapest, and I was running into problems where it just lock. Well, that's it. I needed to bounce it up to standard, and then it became just fine. So low to medium I/O performance requirements for standard, multiple concurrent queries. That and that bottom on both of those, that's the real nugget of truth. Premium, so we're getting into much bigger, higher performance requirements. High availability, so mission critical applications go in premium. Now, there is a variation of premium called premium RS, which I am not sure what the RS stands for. And this would be for I/O intensive applications that don't have the high mission critical requirements. So usually you think about this for like analytical stuff. So you're mowing down big data sets or whatnot. Bunch of stuff about service tier and their attributes. Definitely read through that. SQL database security, it's pretty darn close to what you would have for SQL Server on-prem. One of the big changes that I notice is that I'm fighting firewall rules a lot. So there's a firewall that goes for SQL database, and usually it's like out of the box, it's restricted to certain IPs and IP ranges. So that's one of the things that I work with all the time. So if I'm at home and suddenly my IP address for my cable modem has changed, I sometimes find that I am locked out of my SQL Server database, which is always an adventure, because it always happens at the moment I don't have time. Authentication gets you into the who are you, and you've got SQL auth, and you also have the availability of AAD integration. So authorization, just like SQL Server. So you have row level auth, and you also have the ability to do data masking. So if you've got particular portions of rows that you want to hide from non-privileged users, you can do that. Masking social security numbers, for example. Income, yada, yada, yada. A bunch of videos up online. And now let's go into DocumentDB in the remaining 2 minutes. Now, DocDB is now part of Cosmos DB. Read through this. The test is going to get updated at some point, but when that is going to be, we are not entirely sure. Just keep that in mind.
So reading between the lines of what Ben is saying, the exam that's up there today is probably not going to mention Cosmos DB because it's so new. That's the new kind of direction to look at the way things are going to go. So it's something from an architecture standpoint you need to know. And if you delay too long before you take the exam, then you really need to know it, because at some point, presumably soon, it's going to land on the exam.
And for all the frustration and the shaking the fists at the sky for having changed the branding and the packaging of this stuff, Cosmos DB looks really, really cool. Hides a lot of the stuff that you would ordinarily have to care about. But back into DocumentDB. Document does not equal PDFs or docx. It means JSON document. So you're tossing JSON into DocDB. You've got really flexible storage. It's schemaless, once again. And it's got a query format called DocumentDB SQL, which looks pretty darn close to regular T-SQL. Platform as a service. One of the really cool things on DocumentDB is that you have the ability to do server-side programming. So if you want to get yourself into that anti-pattern of putting business logic in your database and really causing problems for developers 10 years in the future, you can do this now. Yes. Because DocDB can do stored procs, triggers, user-defined functions, and those user-defined functions are written in JavaScript. And here's a link to that. And I am out of time. So videos on that, information, it's all there. Oh, MySQL exists. It's one of the options. So MySQL is a relational database. And you've got roughly 3 options for running MySQL on Azure. So 1, run it in a VM. 2, run it hosted by ClearDB. And then there is something that is in preview right now, probably not going to be on the test, Azure Database for MySQL, and that is up there as well. Personally, I have found that I get much better performance running MySQL in my own VM as opposed to the hosted options. I'm not really sure why, but the downside of running it in a VM is that now I have to worry about backup and redundancy and all that fun stuff. So hopefully my blog does not crash and burn. MongoDB, based off of Humongous. It's another NoSQL option. JSON-like. It's one of the options that falls under Cosmos DB. And I think at this point, I am super out of time. So I'm just going to wrap up. Okay. There are this one. Oh, this is the same one. Yeah, this is like the Cosmos DB thing right here. It's a moving target. They do update it. They do update the test, I mean. And they do update Azure too, which is cool.
By the way, whenever they update it, they do not necessarily let us know. So they're, excuse me, the people that write the test are different than the people that write the content. They're different than the people that write the books. So that was done on purpose by Microsoft. The rationale for that is they don't want people to become, this goes back to the paper MCSE problem. People go out and take the test, study for the test, and not really know anything when they get done. So by having those clear divisions of responsibility, it kind of helps eliminate that challenge.
I think we already said this one.
Yep, we went through that. Oh, great plug. Yeah, Mark Grimes' certification exam overview. To be quite honest with you, this entire event series that I've been kind of working to get going for a few years started off with me attending one of Mark Grimes' 60-minute presentations on the exam. And I'm like, we could make this way better if it was way deeper. But he gives you a really, really good overview, and I stole a lot of his slides. Well, with his permission, of course. And he's actually one of our speakers for this week, so we'll get to hear from him later.
Cool. All right. Oddly, this one it says Microsoft NDA.
Yeah, that's on the format. I need to get rid of that.
Okay.
It's not confidential.
All right, that's it. Thank you very much.
So thank you, Ben. We're going to take like a 10 to 12-minute break. Generally during the break, don't go anywhere. Generally during the break, we're actually going to be doing labs. This first break does not have any labs, though. What we're doing instead is we want to make sure that you guys and gals, are set up to be able to connect to your Azure account from here. If you can't do that, you're not going to be able to do any of the labs. All of the labs are connecting to Azure. So one, you need to log into the portal, make sure you can log into the portal. The second thing is if you have PowerShell capabilities, you might want to go ahead and get PowerShell downloaded and set up so that you can connect with PowerShell, because a lot of the labs will use PowerShell as well, or CLI, either one. And so you have about a 11-minute break. Again, restrooms are in the back. And whenever you get back, go ahead and grab some food on the way back in, but make sure you can connect to Azure. That's the most important part of this break, okay? Thanks.